Hi, welcome to inverse variation. So, inverse variation is similar to direct variation, but they're not the same because inverse variation is where x times y equals k or y equals k over x. Okay, that's your form that you're going to have it in. Before, direct variation is y equals k times x, and that's how they differ. So that's what we learned last time, right? And k is still your constant of variation. So your goal is still to come up with k and plug it into your original equation, which will now be y equals k over x instead of y equals k times x. So inverse variation is division, the y equals k divided by x, and direct variation is k times x, so multiplication. So that's what you need to remember. So our first example, suppose that x and y vary inversely. So y equals k over x. Okay, that's what we know about inverse variation. X equals 7 when y equals 4. So it wants us to write the equation where k is filled in instead of k. So we know that. We also know that it can also look like this, y times x equals k. So I'm going to solve for k that way. I'm going to plug in 4 times 7 equals k, so k equals 28. Take this, put it back into the original equation, so y equals 28 over x. That's all you have to do. So now we're going to find out if the relationship in these numbers is direct or inverse or neither, because it's possible for them to be neither, and that happens. So for all these, the first thing I'm going to try is inverse variation, since that's what we're learning. And I'm going to take my x's and my y's, and I'm going to multiply them together because we said that k equals x times y. So it's the best way to find out. And remember, when you're doing these, they all have to be the exact same number. If one of them is different, then it doesn't work. So once you find one that's different, you can stop, and you know that it's not that one. So first, I'm going to do inverse variation. So I'm going to do 2 times 0.7, and that is 1.4. 4 times 0.35, that's 1.4. And 14 times 0.1, that's 1.4. So here we have inverse. My k is whatever's the same, right? So 1.4. And when you plug it back into the equation, the y equals k over x equation, you get y equals 1.4 over x. That's all you need. So here, again, I'm going to try direct or inverse variation. So negative 2 times 6, that's 12. Negative 12. Negative 1.3 times 5, that's negative 6.5. Well, these are not equal, so it is not inverse. Not inverse. So I'm going to get rid of all this. And I'm going to try direct. So remember that for direct, k equals y over x. So 6 divided by negative 2 is negative 3. And 5 divided by negative 1.3 is negative 3.84. Something like that. And those are not equal. So it's not direct either. So there's nothing else for us to find because it's neither. So let's go over here to C. Again, we're going to start with inverse. So 5 times negative 2 is negative 10. 4 times negative 10, well, that's negative 40. So it's not inverse. Maybe it's direct. So, again, y over x. So negative 5 over 2. This is negative 10 over 4, which is negative 5 over 2. And this is negative 15 over 6, and if you divide the top and the bottom by 3, you get negative 5 over 2. So this is direct. My k is negative 5 over 2. And my equation, remember, y equals k times x. So y equals negative 5 over 2 times x. Simple enough. So one of the big things that we're going to do with our variations is putting them and using them in real life situations. So here, the pressure P of a sample of gas at a constant temperature varies inversely as the volume. Okay, so I'm going to take that information and I'm going to write my general equation. Because P varies inversely as the volume V. Well, I know that my normal equation is y equals k over x. So P varies, P varies, P equals inversely as the volume V. So k over V. That's it. Use the data in the table to write, that's a typo, a function that models this inverse variation. We did that. Oh, we need to use the table. So, pick a point, any point. It tells you that it's already inversely related, so all you have to do is pick one point. You don't need to pick a bunch of them to prove that they're all inversely related. So remember, I can take V and multiply it on both sides. So K equals VP. So K equals 32 times 3. So K equals 96. So my equation is P equals 96 over V. Alright, I did that step. Use your equation to estimate the pressure when the volume is 6 inches cubed. So, volume is 6. So I'm going to take and replace my volume with 6. And I get 16. And my units, pounds per inch squared. Okay, recap. I took my data, or I took what it said, varies inversely. I got my general equation. Then I took my data to find K, and I plugged it back in. Right, I took this 96 and I plugged it back in. And then I took my 6 and I plugged it in where I had the variable. In this case, it was volume. So I plugged it in for V, and I divided 96 by 6. And I got 16. Okay, so it's important that you know direct and inverse variation, because whenever you have multiple types in the same equation, it's called a combined variation. So it can vary directly with 2 letters, and it can vary directly and inversely. So there's a bunch of different ways that you can see it and read it, and you need to know how to go from one to the other. So written to symbols, and from symbols to writing. So the first thing that I look at, or there's also joint variation, and that's this first one. So if you have multiple direct variations, then it's jointly varied. So if you look at the first one, Z varies jointly with X and Y. Well, that's because it varies directly with X and Y. And when I'm writing this, if I look just at the Z varies jointly with X and Y, the first thing I want to do is look at Z varies. Z varies. Z equals. That's my first step. Z varies, so Z equals something. Jointly with X and Y. Jointly. So jointly and directly, they're both in the numerator. So there's our constant, right? You always have a constant of variation. You always have a constant of variation. Okay, remember that. Say it to yourself over and over and over again. You always have a constant of variation. Jointly with X and Y, that means multiplication. Directly means multiplication. So X times Y. The second one, Z varies jointly with X and Y. Well, we already know what that means. Looks like, right? Z equals k, right? Constant of variation, z equals a constant times xy, and inversely with w. So inversely is the division. We know what it looks like. Z equals k over x, or y equals k over x. So instead of having x, we have a w, and instead of having just k in our numerator, we have k times x times y. But w goes in the denominator. So whatever it's inversely by goes in the denominator. Whatever it's directly by stays in the numerator. So last one. Z varies. Z equals directly with x, so constant x, and inversely with the product wy. So inversely wy. Okay? So let's do that. And you need, like I said, you need to be able to go forwards and backwards. So you need to know how to get that. So the mass of a moving object is related to its kinetic energy k and its velocity v by the formula m equals 2k over v squared. Describe the relationship. And when it says describe the relationship, that means use words, not symbols. So m equals 2k over v squared. So m equals, m varies. Okay, you don't have to say the constant, right? But there's something in the numerator. There's 2k. Well, 2 is our constant of variation because it's a number. So if it's in the numerator, it's directly. So directly with k. And then there's a denominator. So inversely and inversely with what? Well, v squared. So with the square of v. And that's all you gotta do. So the k was in the numerator, so it was the direct. And the v squared was in the denominator, so it was inversely. Alright, now we're going from words to equations. So the area of an equilateral triangle varies directly as the square of the radius r of its circumscribed triangle, circle. Yeah. So area varies. And it gives you this information right here. That's not entirely necessary. So area varies directly, so we have a constant, right? We always have a constant, as the square of the radius r. So it's r squared. That's it. The area of an equilateral triangle, for which r equals 2, is 3 root 3. And it's giving you a and r. R is right here, and this is a. Okay, because it says the area of an equilateral triangle, for which r equals 2 is 3 root 3. So we want to find k. We always want to find k. And then we want to plug it back in, because it says find the formula for the area A of an equilateral triangle in terms of r. So we have 3 root 3 equals k. And we know r is 2, and it's squared. So 3 root 3 equals 4k, because 2 squared is 4. Divide both sides by 4. And we have that k equals 3 root 3 over 4. Is that enough? No, it's not enough. We have to take this k and plug it back. So a equals 3 root 3 over 4 r squared. Now we're done. That's our final answer. So here you try these. Make sure you get them written down. Make sure that you write down the entire equation so that when you look back at your notes, you know exactly what it's asking. It doesn't help you to review notes if you don't know what's going on. So make sure you have all of this written down, and have a wonderful day.